All right, let's get to the next session. Last session, we have just continued writing this function. We need to process a vtable entry now. Okay, how do we do that? So the index is here. Yeah, and it's hopefully correct now. And so what we can do now is when I think we let's copy this stuff here. So let's uncomment this. So vtable, yeah, base vtable. Where's base vtable? Base vtable here. Oh, base vtable. Base class type, base vtable. But only if it has a vtable. So if base vtables.empty, then we continue, right? Base class index. This one is wrong here. So we have space entry index. Do we need to do this here as well? Okay, so base vtable count, base vtable count, base vtable count, vtable count, combine count. Base vtable. Base vtable count. Base. Count. Vtable entry count. Vtable. Let's call this vtable count. Let's do combined count. UN16T. Vtable entry index. Base vtable entry index. Entry base entry. So So what if table index? So what if we have a detour? What then? So if they are not equal, then what do we do? Vtable entry index. No. Base vtable entry index. Okay, here we need to rethink this here. So if we okay, so let's say, well, do we always go up here? If the base is a detour and this is a detour, then it's fine. We just go over. If table entry index, I think this one should be here. This way. And then I think we can put this one in here. Can make this const. And in this algorithm, we can't really set this guy here, can we? I don't think so. Okay, but let's get the detours right first. So if base class index, base class, so is the structure is the structure base is the structure so if these are not equal, then we skip this ahead. Yeah, I think this is correct. We skip the destructor if the other side is not a destructor. Yeah, I think this is correct. Okay, let's see what this gives us. It compiles, it's a good start. Should we put maybe some asserts here? Vtable index. Maybe there should be an assert here at the end that says vtable entry index equals oops, vtable count dot combined, right? At the end. Yeah. Yeah. Okay. Then I would assume that to it's class index. We need to make a link between. We should create a link between a function, between a vtable entry and the highest or the lowest base class that it overrides, right? So what we can do is we can do uint 8 t direct base class index base maybe call it vtable entry. Direct. Probably need base offset. Base offset 0. Base class index at offset 0. Yeah. So we can record here. Where are we? Oops. Wrong file. So here we can say entry dot base offset. Should probably mbase offset. Base offset base vtable dot offset. Entry, vtable entry, base offset. Why is this not working? Vtable entry is no member. Base offset. This should also be called offset. Offset. This should also be renamed base offset, and this as well. Is virtual. Oops. Is virtual. Let's do the same here. Detour count. Okay. Offset. All right. Okay, base offset equals offset, and offset in bytes. Vtable offset. Actually, it doesn't make any sense here, doesn't it? Or does it? Base class offset. Index or offset. Base class. Yeah, base class. Base class. I would like to have one identifier that tells us exactly which maybe it should be a class index vtable. Yeah, maybe there should be a, instead of these two, we have one index t m base class index. Let's say bottom, or yeah, we just add a comment. The most bottom base class that this virtual function base class index as invalid index, the most bottom base class over. This virtual function overrides yeah, maybe. Then the question is how we set this thing. It would have to be the most bottom class. We would have to, I don't know what the best approach is. Okay, yeah, there needs to be some approach. Yeah. Yeah. Vtable entry index. Yeah. Okay, this looks good here in principle, but yeah, I don't know how we can get this base class index. It would be good if we had that. Yeah. Base class index. Okay, but apart from that, let's ignore that for now. Let's see what we got so far. Let's see. Oh. I thought so. Okay. What do we have here? Okay, 0, 2. 0 and 2. Vtable destructor 2. Why is this? Base class 0. Right. Right. When we don't have base classes, then we don't really process anything. So what we can say is base class. Here can uint uint atm direct base class index. Well, the direct base class that this virtual function belongs to. It would be nice if maybe it should be a sequence of it's probably useful for something, so maybe we should store that direct base class index. Let's do uint 8t base class count uint 8t base class index static cast uint 8t Okay. And we say if base class count is 0, then there's nothing to do really, right? Done. Otherwise, we will process. Base class count, base class count, base class count. Base class index, base class count, base class index. Okay. And then where's our vtable? Vtable here. Base vtable. Base vtable. Base. Yeah, and then theta continue. And then here we do entry dot base direct base class index. We put that to base class index. There you go. Assert. We expect that we don't have more than 255 base classes, right? 0x11. So one equal ff. There we go. Tables.size. Maybe we move this to the very top. All right. I think this could be better. Let's see. Oh. 4. What happened here? Class overridable. Okay. Let's put a breakpoint. Overridable. 1. I'm not so sure if this should be also a condition. How about we say if class type dot mbase classes dot empty, then return, and if class type vtables dot empty, then also return. There's nothing to do. Then we don't need this. And I think then we also don't need this here. Because it's already in here. Let's try this again. Okay, overridable, vtable, yes. Offset, vtable count. Okay. Detour to 0, 1, 0 index, space, blah. If base class vtable, empty. Mm-hmm. Okay, to base vtable count. Yeah. Yeah. Base vtable. Combined count. Paste. Well, if we get this here, this count, then might as well just put this up there. This here. Vtable, base vtable. So vtables 0. Okay, so the first thing we can do is put this here. And I think the second we do is we move this here. And then we move base vtable entry count. Then we rename it to just vtable count, and then we put here base vtable combined count. Combined. Oh shit. Count. Count. Vtable count. Count. Okay, let's try it again. Good, so base vtable, blah blah, base vtable combined count is detour, base index, okay, override, yes, okay, pure virtual, base entry, okay, one is detour, one, okay. Two, okay. Regular counts. Oh. Right, so we have process two functions. I think what we can do is here, we say, so basically we can remove this stuff here because we already increment this thing in here. Or we remove it. No, we cannot remove it because of this. I think we need to change this here. If base is detour, And if not is detour, then we continue. If not base is detour, but then if base is detour, if is detour, then assert base is detour, right? Otherwise, yeah, I think we make this assumption here. And on the other side, if the base is a detour, but our list is not detour, then we continue. Base is detour. I think so. Is detour, base is detour. Okay. And then we remove this and this. And then we say if is detour, then we decrement available detour count. Well, what do we use that for? I don't know. I think we can also move this to the very bottom. Can we do an else if base is detour, then we check if is detour. If not is detour, then we continue. Else if is detour, base is detour. Else if is detour. Well, that doesn't make much sense. That doesn't make sense. If base is detour, how about else? If base is detour, base. Oh man, why do I have so much problems with this? If base is detour, if the base is a destructor, then so if the base is a okay, how about we say if base is okay, how about if not is detour and base is detour, continue. If not is detour, so the parent is not detour. The parent is not detour. The base is detour. Then we continue. Okay. If the parent is destructor, then we expect that this is also assert. Are these mutually exclusive or not? I'm a bit confused. Yeah. We can also, if that, else, right? So if it's not a destructor, then the base, and the base is then not a destructor, and the base is a destructor, then we continue. Otherwise, we expect that the base is also a destructor. Yeah, I think this makes sense. Maybe. Okay, let's try again. So is detour true, 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 0, 0, good, overwrite, yep. Okay, that looks good. Next entry, base entry, is detour true, true, assert, yes, good, 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 and we are done. Base offset 0, no new virtuals, 2, good, good, 2 equals 2, done. Okay, good. Let's remove this breakpoint. Okay, let's look at this now. Okay, so what do we have? Class count 2, base class type behavior module 2, 46, combine count 48, 48. Okay. Entry. Update module. Is detour true, 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 true? Is override? Yes, yes. Okay. Entry is detour true, true. Okay. Base 0. Okay. Okay. All right. Okay. Here we have a pure virtual, and here as well is not a destructor, not a destructor, not a destructor. 0 is pure virtual. Is implicit. Yes. Very good. This looks good. We're still 48. But you know what the problem is? No, there's no problem. Entry on object created. Module base name. Entries index 3 entries base vtable 48 51. Module is not detour. Pure virtual class update module is implicit. Okay, this looks good. Drawable bound to object. Drawable bound to object is detour no. Okay, this looks good. Implicit. 5. Preload assets. Preload assets. Okay, how about we put a breakpoint? I mean, this looks pretty solid here. Let's put a breakpoint here for the next iteration for the base class. Actually, let's put a breakpoint here. So the new virtual function count should be 1, right? Yeah, 1. So we go 49. Okay, and now now it will also step in here. Yeah, do we care right now? I don't think we care right now. Let's remove this breakpoint. So what I expect now is the next base class. Base vtable blah. Okay. Okay, here we have a problem, don't we? No, we don't. 2. So vtable entry index is 49. It is a pure virtual. And this one as well. There we go. Base class index 1, pure virtual. It's implicit. Yes, yes. Okay, good. And next one is get disabled types to process. And this is also a pure virtual. Not pure virtual. It is an override. Starts with update module. Update module. Yeah, it is an override. It's overrides. Not pure virtual is pure virtual. So here it will assign a name. There we go. Yeah. Yeah. So base entry will now have a name. Update module interface. There we go. Okay, this looks like it works. God damn. God damn. Okay, then let's run it through and let's see if it hits this here. What is the expectation? Will it hit this? Maybe not, actually, because now we really go through all vtables, but maybe I missed something again, which is very, very possible. And we still don't do something quite right. But there is a chance, I would say 50-50, I would say, that we now cover all virtual functions. Let's see. Oh, no, we have an assert. Oh, boy. What happened here? Oh, boy. Radar updates. Oh, okay, we have a problem here. Okay, we have a bigger problem. Yeah, that's not good. That's not good at all. Okay. Radar update. Radar update. Radar. Radar. Oh, okay, so good. Yeah, let's investigate this next session. We have some error here. We need to get to the bottom of it. It's good that we have a search. It tells us that something is wrong. Okay. Then I will take a break here. The next session we investigate. Yeah. All right. Then until next time.